Okay, so we've got another Amstrad 901, and this is a set which the gentleman has not paid a lot for as a spares and repairs set. It's a genuine one, but unfortunately it's had the same thing done to it where the power lead's been bodged in, you know, so we've gone to the trouble to have these mouldings made, and there you go. So I'm not powering it up like that, so there's a double rant on this one. What on earth's all this? Right. Yeah, well, good grief, what's going on here? So if these sets are reverse polarity, it takes all the ICs out, apart from the synthesizer. So if you've got one with a dove protection diode, why is the, you know, these are things I don't understand. Is that instead of what? I'm going to have to look at what diode 10 is supposed to be. It looks, this protection diode looks broken. I think that protection diode is blown apart. And so he did say he's got this. It's where they thought they were overpowered. I don't think they were overpowered. It's got a broken core there, so that's a good one, isn't it? Broken core. We'll need to change the ballast resistor because it's not going to do. Doubt it's going to do more than 2.7 watts with that on it. And then looks like we've got a. I'm going to check that before we move, because it's got a broken protection diode, and then they've applied power reverse. It's going to have. It's going to be actually, easiest thing to do is to connect it to this wired in thing. I mean, it's a nice lead, this, and like the other one, I'll get Mr. Chippy to put the correct plug on the end. That's a short circuit, isn't it? Let's go into 18 ohms, 10 ohms, the best thing to do is disconnect this. I'll get Mr. Chippy to put the correct plug on that, because that's otherwise a nice lead. I'll tell you what the other rant is here. They've actually sent a power mic in with it. You know, are we seriously going to try it with that? This is left over from the days of American illegal CBs being used here, and where torque power is king. So the idea is, and there is a side thing to this, yes, there are people with voice problems and this type of thing could help them, but the speech processor mics, which would be better. All the radios for the UK market are speech processed, so why would you... These mics, when standard replacement mics were available, and these were available, these were cheaper than standard replacement mics. So what does that tell us about the quality? Anyway, I mean every wholesaler did them, and we'll go through to PA with that, but we're certainly not going to be using it on the air, because all you're doing is amplifying. You're amplifying the voice, adding some distortion, and the poor radio's got to knock it back down to the right level. So, absolutely bonkers idea. These are, I say, it's a leftover from an American AM type of idea, but with FM, no. Next time someone sees a policeman with a power mic, let me know. Right, well, it looks to me like this diode is... I'm not powering this setup. We'll put that to one side. I mean, that otherwise... Colin Blow. Well, it looks blown. Right. Let's see if we can find this diode on the board, and let's get rid of this messy link where it's been reverse polarityed. It even tells you on the case which is positive and which is negative. So, you know, how can people get that wrong? And yet, these were $89.99 sets. I think some people have got too much money, don't you? I'm just trying to think where it is. This side. Is it that one? Look like a coil. Or is it there? I think it's that one, because that felt really loose. So I think it's that one and that one. Because that print's going to fall off. And there we are, one disintegrated diode. See, this is a visual inspection without even powering it up. And I've got to do this, even if this set is a no-go. So there's a correct diode. We're using one M4007 because it's cheaper for me to buy 1,000 of those than to buy different ones. These are 1,000 volt rated. Just making sure I've got the spacing something right, because it's not that difficult. Sorry, it's not that easy to insert with all these other components, of course. I'll get that soldered in. What we'll do here make the link with this component lead where the track has been blown away. And then at the same time we'll just look at a few dry joints in this area. The next thing we're going to do before powering it up is, why is that diode there? So diode 10 it says on the other side of the board. Why is it on that side of the board? Right, I'll pause the video and we'll get a service manual. So when I look at the service manual, it's supposed to be 1N9141 N4148 100 milliamp signal diode. So I'm not sure why there's a rectifier diode in there. My fear is that if this is in any way anything to do with safety, this will be far too big to fail in the event of a problem. So let's get it out. I just don't get why it would be that side. What's that about? I know they have to put some, especially on early production sets, these capacitors on the wrong side because they've cocked up on the board layout and they haven't implemented the change at this point. So I understand what that's about. So let's get that in. It's that way round. Right, that's that right. And if there's a fault, I want to see that fail, not stay working. Just have a look for dry joints. They're not prone to them. There's a potential one there. So we'll just look at some potential ones before powering it up. I think he said it lights up, but it's otherwise there's no transmit or receive. And he bought it dead cheap as a scrapper, you know. Crystal's missing, isn't it? That's why it doesn't work. There's no reference crystal. Now you know what? We took the reference crystal off his other set. And I haven't thrown that away yet. It was out of tolerance, but it might not be out of tolerance on this set. So, there you go. Ah, there we are. We're with a fighting chance. So, we'll pop that in for now. See, we haven't even powered it up yet, and we've found all kinds of problems. But I just hope this hasn't been reverse polarity, because it takes out the FM chip and it takes out the bargraph driver chip, the potential dry joint there. The bargraph driver chip's missing, so it doesn't light up, does it? Because it can't. So there we go. Look, nothing there. Bargraph driver chip's missing. We've got those in stock, the 599 if I remember right. I tell you what, there was a time when they They were like 12 quid. Right, so it isn't going to light up properly because the bargraph driver chip doesn't work, because it's missing. Right, so we'll plug in the other power lead Mr. Chippy made for him yesterday, and we'll give it a go. I'm going to plug in our standard test mic. I was looking on the front for the socket. And we're going to switch to PA, and we'll see whether it works as a public address amplifier, because the one we did for him yesterday is the very first time I've ever encountered public address not working on one of these. So we'll plug that into public address. It will click as I plug the speaker in, which is good news. And we'll plug the test equipment into the aerial socket. So one of the things he particularly likes about this set is its low serial number, and I can't fault him there. Right. So it is 1899.5, and it is Amstrad CB901 Japan, and the serial number is 673. That's great. Right, we're in public address mode. Testing 1 2 3 4 5 5 4 3 2 1. 1 2 3. We've got a dirty volume control. We'll deal with that. So the applicator came out and it went on the floor. We're always losing applicators. I've managed to find that. Let's try again. Testing 1 2, testing 1 2, testing 1 2, 1 2 1 2. Right, good. Well, that's a good start. So we'll now put the extension speaker into extension speaker. I don't want to put the test equipment in case it's passing a voltage. I think we're going to have to do all these controls because it doesn't seem we've got squelch operation, which is interesting because that's something his one yesterday didn't have. These are from different sources. It's not like they're all tied with the same brush. So we'll just waggle these around a bit. Put that to centre for fairness. Waggle that round, waggle that round. Switch it back on. Give that one another go, I think. Right, so with the crystal in, we should now have transmit. Let's switch picture in picture on, and let's put the appropriate camera up. We've now lost camera 1. Meters have all moved again, the cameras have all moved again. And okay, so hopefully that will come back on. Yep, key up, and we have 2.8 watts. If we can get this to go above 100, we can use that crystal. It is low, but it's not as low as it was in the other set. And of course that's because of component tolerances. So I'll tell you what, we'll go to the frequency counter. We'll start by seeing whether we can get it anywhere near. I think there's a dry joint on that. It's all over the place channel wise. Right, we'll turn it off. See if we can find some dry joints on this coil. I mean, it looks alright, but something's happening every time I touch it. What we're doing the channel selector switch, because it seems to be jumping to channel 40. We don't need to solder up the other side because that's the display side. We only need to worry about this side, which go to the phase lock loop chip. Right, power it back up and see whether we can get that frequency anywhere near. Right. Well, it's closer than the other one was, but I can't really let it out like that. But having said that, the test gear's only been on for 20 minutes. So we can do all the set and we can make a decision about that later. The trouble is, what scrap sets can I pinch a crystal off? And we're back to the problem. I can buy 20 from AliExpress and find only one works satisfactorily. I can have them made at £35 each. It's cheaper to buy scrap sets, isn't it? So this is never going to do more than 2.7 watts because of that. So here we go. Let's start making some notes. At least we're getting somewhere. And I'll tell you what, let's put in receive to see whether the receive works, because it's with the FM chip seems to be working because we can hear FM. So let's have a, yeah, we've got receive. So although it has been reverse polarityed in the past, it hasn't, it's killed the diode and that has protected it, and it hasn't happened a second time, because that's never been changed. That would have been changed if it had been killed. So it has been reverse polarityed, it's killed the diode and not the radio, which is how it should be. Here we are. So that's this one. Just turn the volume down a fraction. So, I mean, it's well worth doing this. It's because it's a nice radio, low serial number. It's been robbed of parts, and you know it's got some issues which hopefully I've sorted them all out. Anyone seen the pen? There. So, no TX, ref, Xtor, or RX. Missing. So at the moment, I mean, what was it? 2779086 when we started. 2779086. Now that isn't fair because I've put a crystal in which is too low to work in his other set. At least it's his crystal. It'd be nice if we can get that to rise to more than 100, and then he can have his crystal from the other set, because I said this is what it's about. There's a tolerance in components. So on transmit, let's go back to the main meter. Let's see what it's going to be about 2.7 watts, isn't it, with that kind of resistor arrangement? Oh, it's doing more than that actually. It's doing 3.1, which is quite good on a 2.5 watt resistor. 3.1 watts. So let's go to channel 40. Okay, channel 1 then. 3.1 watts. It's channel 40. 3 watts. It's the other way around to usual, isn't it? Low power. Back to channel 20. Key it up. Low power on the test set. And it's doing... Actually, it's doing 350 milliwatts. Now that's going to change when I tune it up. Back to full power. And then... see what the current consumption is. I didn't do that right. They are a fiddly thing, aren't they, these? Could at least have put a button on them. It's 1.14 amps. Deviation on this test set, which means nothing. Have I switched the other test set on? No. So we'll come back to that. Wow, oh, it's over the top there. It's reading on this test set. It's reading 4. We'll do the VCO. So it's channel 1. We're going to need an earth. That's not going to stay put. Right, I want a bit of a crocodile clip lead. What's the chance of being able to find one? We got one on there. No, we've got one there. So put that there. We may as well use that coil as our earth. Not sure why that resistor's like that, but it looks like a modification because it's a low serial number. It doesn't look like it's something silly that's being done. Right, channel 1, far side of resistor 9, we're looking for 2 volts. We've got 0.9, which isn't any good to us. Just a coil for 2. In fact, I'll tell you what, we'll check what the transmit is before I alter it. So we've got 0.9. That can't be right. 0.9 and 0.4. I'm so not sure. I'm going to just connect that to the power supply instead of a coil. .9 and on transmit 0.5. How on earth is that even working down there? 2 and 1.3. Oh, good grief. 0.9 plus 0.5. I've got enough of the service manual here to... Yeah, it's 2 volts, see? I haven't forgotten it wrongly in a couple of days. Right, so we've got 2 volts on receive. Let's press transmit. We've got 1.69, which isn't that far out on transmit. Let's see if I can hold the transmit. Let's put it on low power so we're not heating up the transmitter. So I've got it on transmit. We're test checking the voltage there, and we're adjusting it for 2. Go on into transmit. With the trimmer there. And we've got, it's changing, isn't it? Let's waggle this around. It's got 2 volts on transmit. Let's go into receive. We've got 2 volts there. Let's go on channel 40. We should have something exactly like it's doing, which is there. So that's fine. That's sorted that out. 2 plus 2. It's not like that manual secret. I paid good money for it, but anyone who emails me, I'll send them a copy free. It's not... You don't have to join my club for a week or anything. Right. So I can't do the fairy lights because... Not going to happen, is it? Right, we are getting there. So, unless it does 3.6 watts, we'll be changing the ballast resistor. With it being the early production one, I would send him that back for posterity rather than putting it in my bin. Okay, here we go. See whether we can get a bit more out of it. Select channel 20. You know what, we might get there. Right, we're going to have to take this one out if we can. I'm hoping I can without unsoldering it. Take that bit out, which is the broken bit. I might just be able to kind of ease it out. Shift that to one side. There might be just enough poking out. There might not. Let's just make sure that's warmed up. Trouble is, it's all cooling back down again. Let's try the long nose pliers. Now we're going to have to unsolder it. I think it's those two. Right, so back with this. Is there a possibility that we can actually poke something up the other side? Being very, very careful here. But look, it's coming out. So we put that the other way round. And there we go. That saved him an impossible part. I did have some solder on here, but I think that's gone AWOL as well. It's gone on the floor. That's the one I got wrong. Okay. Power it back up, power supply back on. So where were we? That's dropped the power. Oh, well, it's doing 4 watts. No, it's not. I'm on low power. What a wally. Start all over again. I was going to say, how can it do more than 2.7? Nope, of course it's not going to do it. I'm going to say that would be a first chance. It's doing exactly what it came doing, 3 watts. But at least we've freed up that. Let's get this ballast resistor out and replaced. So what we've got are these 6 watt resistors, so that we've got a fighting chance of the radio doing 4 watts. That's the one. We'll pinch one of the pieces of resistor flex off there. We'll just make sure these, although these are brand new out of a sealed packet, we'll just make sure that the leads are clean. So I want this piece of sleeving to be next to that capacitor. We'll leave that as high as is possible so that it's not affecting the capacitor, because obviously it gets hot. As I've said a million times before, if you ever see these linked out, make sure they're replaced. People can think they're going to get more power, and they can probably get 6 watts for about 2 minutes until the output transistor is destroyed. But it's all over the place. It's not It's not more power on 27 megs. It's all over the place. I've shown before. Most of it's on aircraft band. Right, see what we can get now. Right, so we were at 3.1 watts. We're now at 4 watts. So just run through these again. It's just over the 4. And there we are, bob on the 4. That's brilliant. So channel 1, 4.05, channel 40 is 4. I'm sure the powers that be aren't going to come round for 4.05 on channel 1. The current consumption now will have changed. It will be much higher. It's not that much higher. It's 1.245. 1.245 amps, so we've gone up just over 100 milliamps, and we're getting another 0.9 of a watt. And low power may be anywhere. It could be 100 milliwatts. It could be whatever it thinks it's going to be. Let's have a look. Do you know what? I've noticed this on the early models. It's absolutely 100% 400 milliwatts. I've only ever seen that on the really early ones. When you get to later ones, you sometimes find it's only 180 milliwatts. That's really good. Now, there's no fairy lights. I'm going to have to I'm going to have to put a chip in which has been stolen out of the set, because obviously it's been used for spare parts. And let's see if we can do something with the receiver, and then I'll go for a tea break. Let's plug in the test speaker, which goes to the test equipment, and we'll put an earth on that because we've only got a single wire coming out. And now we can note down the SINADs before we start. Let's just see where we are on the frequency counter. So back to the frequency counter, we're at 27,79101. So we can let this radio go with the crystal we took out of his other set. So that costs him nothing. It's within what we're allowed. So that's brilliant. So we'll set the test gear so that the signal generation is on 27,79100. So SINAD, I mean, this is really good already, and not even touched it. It's doing 0.44. Don't get that on your Unidens. 0.37. .78. Squelch. Oh, that's pretty wishy-washy, isn't it? Might be able to alter that. It's only 2.8 microvolts on full, and on minimum, let's go to the attenuator so you can see what we're doing here. On minimum, let's have that on 0. Put that to standby. Put the squelch so it is active. Threshold. Signal generator back on. Straight in at 0.3. So we want that to be a bit tighter than that. I can't tell you the S meter because the chip's being pinched. So let's have a look. See what we can improve. So have a look at the detector for a start. I'll put 100 microvolts on the signal generator. We'll look at the oscilloscope. We will look at the oscilloscope. And see whether there's adjustment needed on that. Yes, it wasn't at peak. So we'll do the IFs. I'll drop that with the SINAD meter. We'll do that with SINAD meter. Drop it to about 6 dB. Let's put a bit more on than that. I might check those again with the when the S meter's working, because you can see those on the S meter. And then we'll now drop the signal a bit more, and we'll tune the front end. I mean, it's not very far out at all. It's not being messed with. No, nothing's been messed with on. And the only one which was messed with was that final one which had got broken. So I'm not going to do the figures for that because I'm going to put the missing chip in. But when I come back, I think the first thing we'll do is deviation on the test set behind me. So I'll go and take a break, and hopefully I'll come back armed with a chip. We're not going to have one on a scrap chassis, and the reason a lot of the sets are scrap is because they were very expensive at one time. Right, if I can find where I put my other glasses, I'll get up from here. Right, I'm back with you. We'll go over to the other test set, and I'll just see where the deviation is. We had 4 on the Marconi test set. Wallow. Yeah, it's about that there. So get that turned down. We don't want to be transmitting on several channels at once. Wallow. So there we go. Right, we'll get unplugged. I've got the chip out of stock, ready. I think we've got 3 of those left. turn the radio back off, switch the power supply off, and see whether we can install this chip. It might be easy if I unplug the mic. So there's the single inline IC. They're quite a swine to get in. Just make sure we can get it in from this side first. Might have to take the front off. I mean, that's been nicely unsoldered, hasn't it? Got to obviously get it in the right way round. And pin 1 is to the left. And at least solder one leg. With the soldering iron I haven't switched back on. So when this set's used on a radio which has a conventional meter, this chip is unpopulated. If I've got one to hand I would show you, but I haven't. Right, there we go. We should now have fairy lights. Let's put the power back on. Yay! So, S9, let's get that set. Oh, I'll tell you what we'll do before that. Just going to make sure this IF spot on, because when I've got the meter, I can see this as well as the SINAD meter and the oscilloscope, so it does help accuracy. So we'll just drop the signal. I'll turn up the I don't need to turn up the sensitivity of this, it's alright. So I'm just going to run through these IFs again. Just drop the signal a fraction. I might have just gained some. That's exactly spot on. Right, we'll get a new SINAD reading now. It's about 12 dB. What we got? 0.4. It hasn't made any difference, has it? You know what? I'm just going to check this as well. Just check our detector's in the right place. Yep. Right, let's get those SINAD figures. (12 dB) is 4 on the dot. 10 dB, 0.34, and 20 dB, 0.7. So you can see from that we're not getting very much on receiver talk, so it was spot on. It's not being messed with. The detector was a bit out. That's sorted. So let's sort. We'll do this meter. So we need 100 microvolts on the test set. It's reading plus 30. Now I want it to read plus 30, but only just. I'm on the squelch, aren't I? That's the. That's it. Just want it to hover on the 30. Like that. You can end up otherwise with plus 30 never lighting. There we go. We're just how we want it. Now we'll do the squelch while we're fiddling about with that. The squelch is now to full. Let's see whether we can get it to close. We can. See whether we can get it to close at that. We can. See if we can get it to close at that. No. Let's go over to the attenuator so you can see what I'm doing. I'm up to 30 microvolts. Let's put this to full then. Not quite full. There we are. That's how I want it to be, 100 microvolts. I didn't think we were going to get there with that. So turn the squelch down, put the signal generator to standby, park it at 0.3, set the squelch to threshold, signal generator on, still got 0.3. That's very good. I didn't think we were going to achieve that. We've now got that working again. It's 100 microvolts as it should be, and we just need to do the transmit power meter. So go back into transmit on the test set, turn the volume down, press transmit. We've got all the bars lighting up. We've got the full 4 watt output, and I want it to, again, not quite like the 5th bar. Because then we'll know if there's a change in SWR. Pop that on low power, it should be 1. It is 1. I'm going to go over this with isopropyl alcohol. And before we do that, I'm just going to put the... I'm going to put this back in the PA speaker. Switch to PA. Testing 1 2, testing 1 2, testing 1 2 1 2. And what I want you to now do, and this is just as a courtesy to the customer, because we don't do this, is we're going to connect up this power mic. Where have I put that? I put it somewhere seconds ago. Testing 1 2, testing 1 2, testing 1 2. But it's so easy to get the volume on these things wrong, and you end up with awful audio. So testing 1 2, testing 1 2, testing 1 2. It does actually work. I'll send it back with the radio, but no. Right, isopropyl alcohol time. I'll switch the power supply off. So we have turned a scrap set into a working set, and we've used his crystal from the set we did the other day, which wouldn't work in that set, into this set, where it works fine. And that's because of component tolerances, which is why you have the adjustments in the first place. It's not channel hopping out anymore either. That'll have to dry. It'll only take a couple of minutes. Whilst that dries, I'll put the lids on. Because we can't power the set up, I'll see if there's continuity on this speaker. Yep. So unless it's got a nasty cone, that should be alright. Because he's lucky there. A lot of the time the speakers have been robbed on sets which have been used for parts. So he's had his own crystal back. He's had a BA656 bargraph driver chip which had been pinched out of the set. He's had a BA656 bargraph driver IC missing. I'll just put no fee there because when it gets billed, he's had a 1N914 and he's had a 1N4001 and he's had a 3 ohm 6 watt resistor. So that's not a big component part count considering this was a scrap set. And he can have his original Amstrad modified resistor which made the set do 2.7 watts or 3.1 watts in this case. Amstrad, I think, were under the misguided impression that the sets were coming out doing too much power. I've got a sneaking suspicion it wasn't the DTI that told them that, but probably testing it with a meter aimed at the hobby market rather than something like a oh come on, Bird through line model 43, which is industry standard. Right, get these lids on. He needs some screws because he doesn't have any. Let's hope the screws haven't been mashed up. We've got the RS ones. So it'd be nice if these holes haven't been mashed up. So Mr. Chippy's rebuilt that lead into one with the power plug on, so that it's done properly. I can feel that's kind of tight. It's like somebody's had a self-tapper or something, and the thread's not as it should have been. I wonder when this last worked properly. I think he said in his letter that he originally had an Amstrad 900, and that's something he ought to get himself. And they're always genuine, the Amstrad 900s. There are no fake versions of those. So I'm very pleased with the outcome. Let's see if it still works. We'll plug it on into the aerial instead of the test gear. Let's switch the test gear off. And then we're doing on the air test. Mark's still here, so he can join in. He can be cameraman for the 5 mile point. How did I say that? 5 mile point camera. Let's put that in extension speaker. Switch the power supply back on. I've never seen the VCO so out for underset still work. There you go. Yes, internal speaker works. One low power. Banana, Roger. Sounds like the band's still a bit noisy. We have East Europeans coming over. Testing 1 2, testing 1 2. There we go. One Amstrad 901, genuine Japanese. Resurrected from a scrap set. Thanks for watching.